So welcome back to the second workshop for Info 640. We're going to get started today with making a bunch of visualizations. So we're going to go over a few introductory visualizations. We're going to use the Ggplot library that comes installed with the Tidyverse library in R. And the reason that we're jumping into basic visualizations so early in the course is that the relationship between variables within a data set is often easier to understand and identify when you're using a visualization. It's way easier to look at a graph or a chart than it is to look at a table of numbers and understand their relationship. So we're going to explore a few very basic visualizations. We're going to do scatter plots and line charts and bar charts, things that are really straightforward. You can make these types of plots in almost any program or software that processes numbers. So you could do this in Excel, you could do it in Numbers, you can do this in Google Sheets or in Python programming language. So there's nothing special about R for this in particular. However, the program that we're going to use is called Ggplot, which stands for Grammar of Graphics. And that's important because the foundations for making all of these very simple plots are also the founding principles for making more complex plots. So every single plot that you use will have three components. First, it'll have a coordinate system, or a place where the x and y values, the x, y, and z values are all living within. And it will also have a data set. Obviously, this is where your data is coming from. And then it will also have the visual marks to display the data, or the aesthetics. This is going to be abbreviated by AES throughout Ggplot. All right, so once you have those three components laid out and the relationship between them, it becomes really easy to take the various basic building blocks and develop those further. So we're going to get started by asking questions about cars. Now, it might seem a little odd that we are focusing here on cars rather than something else. However, we're going to use the MPG dataset. This is a really famous and really well documented dataset. So if you're having any problems, you should be able to find lots of answers to questions on the internet just by typing in RMPG and then whatever error message you're getting. So we're going to start down here in the console by loading the library Tidyverse. And the way that we do that is we type in the word library and we open parentheses, and it starts to give us some suggestions. So we're going to start typing in Tidyverse, and you see we have the Tidyverse library already installed. And it's going to load that in, tell me some conflicts. These are not really problems right now, and you might actually have a more up-to-date version of R, so you may not see these conflicts. If you do or if you don't, not a big deal. If, however, you get an error message saying that the Tidyverse library is not installed, I'm going to have you go ahead and install it, and you type install.packages, and then open parentheses, and then type in the word Tidyverse. I'm not going to run this because obviously Tidyverse is already installed, but if you don't have Tidyverse installed, then you can go ahead and install it that way. Okay, so we see here that within the Tidyverse package comes this subpackage, Ggplot2. So we're going to use the Ggplot2, the Grammar of Graphics library, to make our first plots. So the first question that we want to ask is if cars with big engines use more fuel than cars with small engines. So let's, think about this for a second and check out if we have a data set that can help us answer this question. So I know that we do have a data set that can help us answer this question. That is the MPG data set. So let's see what's available in the MPG data set. So we're going to type question mark MPG and hit enter. And you see over here, we get a whole lot of information about what we find in this data set. So it's fuel economy data from the EPA. It contains data from 1999 to 2008, and it's kind of used as a proxy for the popularity of the car. So we see that we have a data frame with 234 rows, so 234 data points, and 11 variables, or 11 features, right? And we have the manufacturer and model name, the engine displacement in liters, the year of manufacturing, cylinders, transmission, if it's a front-wheel drive or four-wheel drive, city miles per gallon, highway miles per gallon, fuel type, and the class or the type of the car. So we're going to go ahead and look at some of these variables and see the relationship between them. And if you, like me, don't know that much about cars, the engine displacement in liters is a good proxy for the size of the car, or it actually is the size of the engine of the car. Okay, so we're going to look at the displacement as related to the highway gas mileage. Okay, so we're going to start by typing Ggplot, and then we're going to open parentheses, and the first thing that you always pass to Ggplot is the data. So we're going to say data equals, and then I want it to pull from the MPG data set. Okay, and then we're going to say plus, and then geom point, and you see we have all of these different options. So it's going to be really helpful. We will explore a lot of these in future classes, but for today we're just going to use point, and we're going to say the mapping is equal to AES, or aesthetic, and our X values are going to be the displacement, and our Y values are going to be the highway mileage. Okay, and we go ahead and run that, and it takes a minute to think, and then you should see over here a plot looking at the displacement and the highway mileage. And we see some a pretty even trend here with some outliers, right? We would expect that the larger the displacement, so the larger the engine, the fewer highway miles we get. And we do see that that's kind of a relationship going on here. What's probably going to be interesting to us are these outliers that don't really fit into that pattern. And we'll see why that is in just a minute. All right, so let's break that down a little bit. So with Ggplot2, you always begin your plot function with Ggplot, and just open parentheses, close parentheses. So let's type Ggplot here, and we get this very empty coordinate system. If your graph disappeared, it worked. Don't worry. This is what we are always adding our layers to. So once you have your Ggplot, the first thing that you add is the data set that you want to use in the graph. So let's go ahead and do that. We'll do Ggplot, and then we'll tell it, okay, the data you are going to use is the MPG data set. So Ggplot data equals MPG. Again, you have your plot over there that nothing happened on, and that's what we expected, because we didn't tell it what to do with that data set. We just said, hey, this is the data that you're going to be drawing from, right? And then you complete your graph by adding some layers to the Ggplot. So the geometry point, or geom underscore point, adds a layer of points to your plot, which then creates a scatter plot, right? So that's where we go, Ggplot, open parentheses, I'll tell it the data is MPG, and then we're going to add to that the geometry point, and that you're going to map it in such a way that the aesthetic will be X equals displacement and Y equals highway mileage. Okay, so we said, hey, go and put some points out there, and show the relationship between them. Now I have one too many closing parentheses here, which means to me that I forgot to close something, and that's where we forgot to close it. So we go ahead and map that again, and you see our points have been laid on top of our coordinate system. So you might be wondering about this mapping function that we called. So every geometry function in Ggplot requires a mapping argument. So no matter what the geometry function, you have to give it this mapping argument. And this mapping argument defines how the variables in your data set are going to be mapped to their visual properties. So mapping always has an AES, or an aesthetic, because the aesthetic tells it how to map those variables. And in order to plot points, we have to have an X and a Y. So on a two-dimensional Cartesian plane, which is what we're going to mostly be working with, probably not doing any three-dimensional in this course. On a two-dimensional Cartesian plane, you always need an X and a Y. So we tell it which variable I want to be X and which variable I want to be Y. And this is really powerful because ultimately this serves as a template. So in the notes as well as on the cheat sheet, you'll see this template that you have Ggplot, data equals the data set plus whatever your geometry function is, and then you pass the geometry function, the mapping equals the aesthetic, and then what your X and what your Y values are. So we can go ahead and play around with this right now. I'm going to ask you to take a minute here, pause the video, and use some different geometries. You can use the same X and Y values, although feel free to play around with the different X and Y values as well, but just try out some different geometries. You can try a line, you can try anything else that is offered by Ggplot. So go ahead and take a minute now and play around with the different geometries that you can use. All right, so hopefully through your experimenting and playing around, you found some graphs that broke. Some geometries do not work for plots like this. So I have an error message here that's warning me that geometry density, the density plot, requires the following missing aesthetics. Why? Well, I passed it a Y, so why it didn't work has more to do with how that plot gets made as opposed to how many variables I passed to it. I passed the wrong kind of variable to it. And hopefully you also found some geometry types that just don't make sense. So we have this one here. We asked it for an area plot, which is something that does not make sense for this type of data set. Later in the semester, we are going to talk about which types of data make the most sense for which types of plots. But for right now, we'll just accept that the best type of plot for this data set is a scatter plot. So let's go back up and get our scatter plot back. I'm using the up cursor to go through these lines so that I can see the things that I've already made. So I hit enter on that, and we should get our scatter plot back. Fantastic. So as we were saying earlier, we see a clear relationship here between the size of the car's engine and the mileage that it gets. And we see, a decreasing linear relationship, as we would expect. However, there are some outliers. So these two out here are outliers, and these out here are outliers. It looks like these cars, whatever those cars represent, whatever these dots represent, those cars somehow have large engines, but really high miles per gallon. So there's probably something going on with those cars. We could hypothesize about these, knowing what we know about cars. Maybe those are hybrids. Maybe those are sports cars or something else that has a large engine, but an otherwise either high gas mileage or small body and therefore high gas mileage. So let's go and try to investigate that a little bit further. So we're going to try to figure that out by mapping the type of car to a class variable, or a type of car to a color variable, okay? So if in fact these are hybrids, then they should be classified as compact or subcompact or something along these lines. Now, this data set goes until about 2008, so there were no hybrid SUVs at that time like there are today. Okay, so let's go ahead and try to add a third variable into our graph here and map the class variable with color. So I'm going to use the same sentence that I've been using. The Ggplot, I'm going to pass it the data is an MPG. The geometry is points. But here in the mapping, our aesthetic is going to be X is displacement, Y is highway mileage, and then color will be class. And we're just going to use the class variable. Okay, and we'll hit enter there. And we say, I made a typo. So that should be a comma and not a period. If you get something like that, go ahead and fix it. You know, it's not uncommon to make errors like that. Okay, so if we go over here, we have this very, very colorful plot. And what we see is that a lot of our outliers are actually two-seater cars. Now, that doesn't seem like a compact or a subcompact car. Compact and subcompact cars are denoted by the yellow and the purple. So this outlier here is a subcompact cars, but these outliers are not. So what other type of cars have very large engines and very good highway mileage? Well, if we think about it for a second, and you really like cars, you might say, well, that's probably a sports car, and you'd be correct. So sports cars have extremely large engines, but since they're so small, they also get very good gas mileage. So that explains our outliers over here. And if we look at our outliers up here, we say, what on earth is getting such amazing gas mileage? And we see that it's subcompact cars, which have very small engines and get incredible gas mileage. So here we see that R very smartly took all of the categorical variables in our data set and mapped them to different colors. So here we have 7 different colors, even though you can't really see the difference between minivan and pickup or possibly midsize. The colors are not very good colors, but there are 7 different colors, right? Now, let's try and see what happens when we do something else, when we map our class, our car class, to the size variable rather than to the color variable, okay? So we will say, go back over here, go up, and rather than color, we say size is equal to class. Okay, now we get this really useful warning here. So our warning message says, using size for a discrete variable is not advised. Let's break that down a little bit. So we have two-seaters up to SUVs, and while mentally that might form kind of a continuous variable that one is smaller than the other and, you know, continuing on, really these are categorical variables. There is no linear relationship to them. There is no ordered relationship to them. However, something like size does have an ordered relationship. So we expect that small dots, small points, to be related to something small in our class variable. So if we had 2-seaters, 3-seaters, 4-seaters, 5-seaters, then this size scaling would make sense. But since you can't necessarily say that a compact car is smaller than a subcompact all the time, because it's not, then these are not ordered in any kind of a quantitative way. They're ordered by alphabet, so they're ordered in a qualitative or a categorical way. A better thing to do would be to map them according to shape. So rather than using size, we could use shape here. So we hit the up arrow and we got our line again. And rather than saying size, we're going to say shape, right? And we get another error here because we don't actually have that many different shapes to use. We only have 6 shapes in our shape library. So R very helpfully said, I only have 6 shapes. Your 7th shape is just going to have to get cut out. So it cut out SUVs for us, saying, I don't have a shape for you. It couldn't repeat the shapes again because then 2-seaters and SUVs would have the same shape. So it would no longer be a variable that we can distinguish because they would be grouped together. One way to deal with this is that you could transform your data and group some cars together. So maybe you'd want to group compact and subcompact cars together and say they're one category, they get one shape, and then go through those. We didn't get this discrete variable warning because shape is very good at showing categorical variables. It's not discrete. It does not say one shape is larger than another shape. They're just different. They're unordered. All right, so hopefully by now you're getting the handle of how you can use the aesthetic for both categorical and numerical values. One other thing that I want to show you is how you can set your colors or line weights or things like that according to whatever you are looking for. So let's say that I want all of my points to be blue, right? I really want to have blue points there. Maybe I'm communicating something using blue. I have blue in this plot and red in that plot. Whatever reason, I want to have blue points. So I'm going to get rid of this last variable here. And I'm going to close the parentheses on my aesthetic. And I'm going to set the same color for all of my points. So I'm going to say color equals blue. And my blue is in quotes because it's a string that's being read and it's not a variable within the program or within the language. The reason that I wanted to close my parentheses here, whereas in other plots I've been keeping my parentheses open to include that last class, is that here I'm having a uniform color for all points in my plot. Whereas previously the aesthetic referred to one of my variables. It was a categorical variable, but it was still one of my variables. This time color doesn't refer to any of my variables. It just says something about the plot more generally. It says, hey, I want all of my points to be blue. Okay? So hit enter here and you should get some blue points. You can use pink, you can use purple, you can use red, whatever you want. So this is the one way to set the visual appearance of our plot. Other things that you can set are the size of the point in millimeters. You can set the shape of a point as a number. There's actually 25 built-in shapes. You can look this up and find it on the internet. and a whole bunch of different ways to modify the appearance of your plot. All right, so there's one more thing that we're going to do in order to change the visual appearance of our final plots, and that is to use something called small multiples. You'll see throughout the course of the semester I'm a huge fan of small multiples because oftentimes it helps you break down your data and illustrate more variables than you would have been able to otherwise. But before we get into our small multiples, we need to remind ourselves what variables we have access to in this data set. So I'm going to go back over here, and I have the tab Plots open here, but I remember that I asked for help at some point. So over here on the Help tab, I have the description of the data set. Okay, so here I have all of the values that are in the data set, and I'm going to make a hypothesis that maybe there's a difference between the front wheel or rear wheel drive status of the car and something about the fuel efficiency and the engine displacement. Okay, so I don't really know if that's going to be true or not, but I'm going to break those out and see if we can get better results by looking at how the car drives. Okay, so I want to break these into 3 different subplots. So I'm going to go over here and I'm going to type in Ggplot, and then I'm going to pass data equals MPG like usual. I'm going to go plus geometry point. I'm still using my point, not a line, and my mapping is going to be the aesthetic, where I have x is equal to the displacement, y is equal to the highway mileage. And here, outside of the geometry point, I'm going to say add to yourself a facet grid. So facet grid is what will break our plane up into multiple different planes. So this will take our one Cartesian plot, and I'm going to say, hey, make multiple Cartesian plots from this, and break those Cartesian plots down by the DRV value. Okay, and I'm going to say, okay, look at it from the DRV value there, the drive, and then the tilde that you see up in probably the upper left hand corner of your keyboard, and then a period. We'll hit enter here. Okay. And then I have my plots broken down by the drive value. So up here I have 4-wheel drive, it says it over here on the right. I have front wheel drive, and I have rear wheel drive. This is really, really hard to see, so if you can't see it on yours, I completely understand. Later on we will look at how to change this, the size of the font to make it much larger. So I have my 4-wheel drive vehicles, my front wheel drive vehicles, and my rear wheel drive vehicles. Interestingly, it seems that my front wheel drive vehicles are a little bit smaller, whereas my 4-wheel drive vehicles are spread throughout the engine size range here. And the rear wheel drive are only these larger cars. So that's an interesting little insight into our data as well. Now we might not want to have them all stacked on top of each other. We might want to have them all next to each other, which is a very simple change here. So I'm going to use the same piece of code, but if I want to have them stacked horizontally rather than vertically, I just type period tilde DRV, right? And then we have them stacked horizontally rather than vertically. So at this point you might be wondering what exactly we can do with all of these plots. So one thing that I'm going to show you is how we can find a line of best fit. So we're going to go back to our original plot that's just the one plot of all of the points, and I'm going up through the records here, and I find my Ggplot data equals MPG plus geometry point, and then my mapping is AES. My mapping is the aesthetic is X is displacement and Y is the highway. All right, so I'm back here at my plane plot. So now I want to make a line of best fit. I'm going to copy that line again, and then I'm going to add to that a geometry smooth. Okay, so I'm just going to add here plus geom underscore smooth. There we go. And then my mapping is going to be the same aesthetic. It's going to be X is equal to the displacement and Y is equal to the highway miles. But then I need to tell it how, oh, what did I type there? Then I need to tell it how to break that apart. So I've lost it, so I'm going to retype it. My geometry is smooth, and my mapping is equal to the aesthetic of having the X is equal to highway miles, Y is equal to, or X is equal to the displacement, and Y is equal to the highway miles. There we go. And then I need to tell this line of best fit how to calculate itself. And I'm going to say that the method is a linear model, or LM, and that standard errors equals false, because I don't want it to calculate the standard error. Again, throughout the semester, we're going to look more at what linear models are and what that standard error refers to. But this quite satisfyingly gives us a line of best fit that shows that we do in fact have a decreasing linear relationship between highway mileage and size of the engine, as illustrated by this nice blue line. All right, so at this point, I would like you to go through and pick two different variables from the MPG dataset, which again, you can find what all of the variables are over here in the help screen. And I would like you to create a scatter plot using the geometry points and both a facet grid and calculate the line of best fit using a linear model for your scatter plot. So go ahead and pick two variables that you think are probably related, maybe may or may not be related. You may want to pick city mileage, or the number of cylinders in the car, or the year of manufacture, to see if cars have gotten more fuel efficient over the years. So come up with a question related to two of these variables and use a scatter plot to answer that question. If you are really not interested in looking more at cars, you are welcome to look at a different data set. You can find a list of the data sets in the Ggplot library by going to the Ggplot website at ggplot2.tidyverse.org. There's a list of the data sets that come included there. You're welcome to pick any data set that you want to work with. Just make sure that you can make a scatter plot like we've done here, as well as a line of best fit, and illustrate it with a third variable using the small multiples that we've looked at. After that, we are going to go ahead and look at a bar chart and the interesting quirks that arise out of using a bar chart and what that tells us about plotting. So go ahead and take about 10 minutes now and do the exercise that we just did using a different data set or different variables from the MPG data set. Look at bar charts. We're going to first take a look at the diamonds data set. So go ahead and type $diamonds to find out more about the diamonds data set. Okay. So it's the prices of, a bunch, 50,000 round cut diamonds. There's a whole lot of variables in this. There's the price, the carat, the cut, the color, the clarity, all of these things. There's 10 of these variables, how big it is, all of these things. We are going to worry primarily about the cut. So we're going to make a bar chart, and we're going to say Ggplot. We're going to pass the data equals diamonds. We'll close that. And then we're going to say we want a bar chart. So we'll just say geom_bar. Our mapping equals our AES, our aesthetic. And for the X value, we're going to say the cut. We want to look at a bar chart of the cut. All right? And because it's a bar chart, we only need one variable in it. So hit enter, does a little thinking, and here we have a bar chart of the cut. What's interesting about this, and what is implicit in bar charts and actually every other geometry, is that over here we have count. Now, there's no variable in our data set that is count. We can go back and look at our data set. We have, price, caret, cut, color, clarity, XYZ, depth, and table. There's no count there, right? Go back and look at our plots here. This count is an implicit statistic that's calculated by R. You can override the defaults here. For the time being, I'm going to say that you probably don't want to override the defaults. But what R did was it said, okay, you want a bar chart. I'm going to go out and make another calculation, and I'm going to tally up how many of each row has this variable. So I'm going to look at the cut column, and I'm going to say, approximately 2,000, it's probably 2,000 of those rows have the value fair, and 25,000 of those rows have the variable ideal. And since I can recognize that that's a categorical variable, I'm just going to count those up and plot those on the plot. Now, we don't often think about the calculations that are going on behind the scenes, but we've actually already dealt with this one time over here with the smooth. When we made our line of best fit, R was actually going out and saying, okay, I'm going to do some kind of calculation. I'm going to use the linear method, and I'm going to figure out how to plot this line. The same thing is happening here. So even though there's no count variable, our environment is able to go out and say, hey, I'm going to tally this up so that I'm able to make the bar chart. Now, if we go back to thinking about our bar chart, another type of bar chart that you see is one where every single column is 100% and each of the bars represents a proportion. So let's look at that type of bar chart here. Let's do Ggplot, and we'll pass data equals diamonds, and then our geometry will still be a bar. Our mapping is equal to AES. X will still be the cut, so each one of our columns will still represent the cut. But instead of just ending it there, we'll say our fill is equal to the clarity. So this is the clarity of each one of the diamonds, and we have to pass it another variable, position. And we'll say that the position comes from the fill. Okay, so we'll go ahead, this needs quotes. Position comes from the fill. And we got an error there because I misspelled geom, as you might have caught as we were typing this. So the clarity is each one of the bars is going to show the breakdown by clarity as well as by cut. So for the fair cut, the clarity has the greatest proportion of the highest clarity, right? So the of all of these, the biggest proportion of the highest clarity is in the fair cut. Right, so we can go through and then compare each one of these columns. So even though, with the other type of bar chart, with a plain bar chart, we have, fill and then good and then very good, and they increase as they go along. Here, they've all been raised to 100%. And now we can judge the proportion of each of the clarity variable against each cut, or against each cut variable. This is often called a stacked bar chart. And really, these are the two types of bar charts that you're going to see most often. There's one more type that you might see, which is a grouped bar chart. This one can be somehow difficult to read just because it gets really noisy really quickly, but let's go ahead and take a look at it. So this is going to show a bunch of bar charts together for each variable. So we are going to use it on the cut, the clarity, and then the position we're going to call dodge. So if we go Ggplot and we pass it our data variable, our data is still diamonds, and then we are still making a type of bar chart. Our mapping is going to equal the aesthetic of X is going to be our cut. Our fill is still going to be clarity, so the color will still be clarity. And the position is going to be dodge. And really the way that I know that the position is going to be dodge is that I read the docs. The cheat sheet that you got from the website and in the course handout goes through what each one of these variables are and how you use them. Very usefully broken down by how many variables you have. So we go ahead, we type in dodge, and we see that we have grouped bar charts now. So the benefit of this type of bar chart as opposed to the last one, as you might be able to tell, is that this represents proportionally how many are fair versus how many are ideal. It is, however, very difficult to compare percentages across each variable. With something like this, you might want to use small multiples. Now, we used small multiples in the previous exercise, so if you wanted to show this with small multiples, I'll have you go ahead and try out what you think that would look like. So go ahead and pause the video, take a couple of minutes to figure out how you would do this with small multiples, and we'll be right back. All right, so hopefully you've taken a couple of minutes and looked back through what we've already done, and you've done something like this, where you say Ggplot data equals diamonds plus geom bar mapping equals AES, X is equal to the cut, our fill is equal to the clarity, and the position, and rather than having a position value, we use the facet grid. So here we add the facet underscore grid, and we're going to have clarity space tilde dot. Oh, right. Facet grid, not grad. And our plot over here has each one of the clarities broken out and each one of the cuts separated as well. You can easily make comparisons across each one of your variables. All right, we are going to move on now, and I'm going to have you look through some of the data sets that are available on the Ggplot tidyverse and pick one more to make a bar chart and answer a question about that data. So the types of things that you're going to want to be able to answer are things that center around counts in the data. So your question is probably going to start with something like how many or what is the most. So go ahead, take a couple of minutes to look through the data sets, see something that might spark your interest, and create another bar plot. And once you've finished, go ahead and download your entire project and send me either the project or a link to the project. And I look forward to seeing you next week. Have a good night. Bye.